So okay. So electric field, we know already that if we have this electric dipole, right, and there is some separation, let's say this is P. And if we calculate the electric field at this axial line, so at this point, this is called the axial point, right? Kyle?
Yes.
And if I calculate the electric field at the perpendicular bisector, so this is A, this is A. And if I calculate the electric field at this point, so this is the equatorial point, right?
Yes,
Right. So what is E axial? Do you remember?
2kp by x 2kp by x square plus a square.
X square plus y square.
That's the point.
Yeah, just assume that for the ideal dipole, this R is very.
We are asking at general point.
Yeah. Yeah, so R is very greater than this. So you can neglect this A. So this would be simply R. And what is E equatorial?
2kp by
2.
kp.
Yeah.
Kp by x.
RQ. Always RQ. So whenever you have a dipole, the electric field varies as 1 over R, right? So for the axial case, this is the direction of the dipole moment, right?
Yes, sir.
So for the axial case, this is again same as the direction of the dipole, right? The electric field is same as the same direction as the dipole moment direction, right? Right, Tariq?
Yes, sir.
And for the equatorial case, the electric field is opposite to the. So electric field is opposite to the direction of this dipole, right? -3. Understood?
Yes, sir.
So if I draw only the diagram of the electric field, so this is dipole moment, and this is the axial, and this is the equatorial, right?
Yes,
Understood.
sir.
So now the question arises that what would be the electric field at the, let's say this is A, this is A, this is P, right? And we are calculating the electric field at this point. So this is neither the axial point nor the equatorial point, right?
Yes, sir.
So this is making an angle theta with this type. Okay. Understood.
Yes, sir.
So it will we divide this dipole electric field in 2 components. This is E1 and this is okay. And then we take the resultant of these guys. So this is theta and this is phi. Right, so this is the electric field at each general point. This electric field is equal to So in my previous lecture, I have derived this. So you just remember that what is the magnitude. This is K2 by R cube root of 3 cos square theta plus 1. So just remember this. This is the magnitude of the electric field at the general point. Understood?
Yes, sir.
So this is the and the angle is this tan phi. So this tan phi is equal to tan theta by 2. So this is the direction of the electric field. So this is the electric field at general point. Understood. So just remember these two formulas. And if you want to look at the derivation, so go through the previous video. Okay. Understood, Tarif?
Yes, understood.
Yeah. So let's say that if I want to, okay, so I have done 2 questions based on this. One was this. The electric field at general point is perpendicular to the dipole moment. Find the relationship between theta and phi. So we use this tan phi relation and then calculated the theta. Okay. So what I can do is that let me go ahead and you see those video lecture, and if you have any doubt, so please ask. Okay.
Okay, sir.
Yeah. So just write this one down. These one and just note down this type. Okay. So we have this dipole, and we are calculating the electric field at this point. So what is this is the dipole. Okay, this is the electric field at the general point. And this is the way to understand. Okay. So please quickly note down these 2 formulas and then yeah, noted.
Writing.
Oh,
Yes, sir.
yeah. So this was the electric field at the general point. Right. Now, this was another question that we were doing. Torque on electric type. Right. We had this. So we had this electric field, right? And this is not chemical, right? So we have this electric field and some dipole is placed. Right. So and this is the angle theta that it makes. Okay. So this will experience some torque. This is the direction of the electric field, and this will experience some torque. This would be this. Right.
Yes, sir.
Because for this, we have this kind of force that is acting on. And for this charge, we have the force which is acting in this direction. So this will generate a couple, right? This will generate a couple, and this will give us this rotational. Right, so we have this torque, so this will generate a couple and this will generate some torque, right? So this would be the perpendicular distance and torque would be perpendicular distance into the magnitude of the force, right? So this will give us this torque, which is P cross E. Right, Tariq? This
Yes,
you have,
sir.
yeah, this you have done in your class, right? Yeah, so let us do this problem then. We have we have an electric dipole which has fixed dipole moment P, which makes angle theta with respect to x-axis. So we have this electric dipole which makes an angle, this is P, and this makes an angle theta with the x-axis. Right, which makes when it is subjected to an electric field, so one electric field is E1, which is EI. So this is in the direction of x direction, right? Right, Tarif?
Right, sir.
So the torque would be simply magnitude of torque would be PE and this sine theta, right?
Yes, sir.
And this is tau 1, only we are considering the magnitude. And for the case of this second electric field, which is root 3 EJ. So this second electric field E2 is in the y direction, right? This is in the y direction. Okay, Faiza has. Yeah. So this electric field in y direction and this magnitude is root 3, right? Root 3E. This is right. So what would be tau 2? Tarif?
Cos theta.
Yeah. Oh, no. So this would be P and this E2 and then sine of, because torque is P sine theta, not cos theta, right? Right. So
Yes, sir.
yeah, P E2 sine of what is the angle between E and P?
90.
So this would be 90 minus theta. So yeah, this will be eventually cos theta, but not P cos theta because cos theta is the dot product, right? This came due to angle which is 90 minus theta, right? Right. So E2 is root 3E and cos theta. Understood? Understood, Tariq?
Yes, sir. Understood.
Yeah, Faiza, hello. Assalamu alaikum. Hi. So Faiza is here, right? Yes, Faiza. Assalamu alaikum. Yeah. Okay, so Faiza, we were just discussing this problem of torque on electric dipole. Right. So you already know that when we place an electric dipole in the external electric field, so this will experience some rotational force because the magnitude of translation force is equal and opposite. So this will cancel out, but it will experience a rotational force, torque. And this is equal to P cross E. So this you have learned in your CBSE course. So Amna ma'am has taught you this. Right, Faiza? Yes. So this torque comes out to be P cross E when placed in external electric field. Right. So we have this question that a dipole moment, a dipole is placed whose dipole moment is making an angle theta with the x-axis. This is the x-axis and it is making an angle theta, right? So we know that torque is Pe sine theta, only the magnitude part, right? And the direction is calculated with this right hand thumb rule. So, but we are only considering this magnitude. So we have this electric field which is in x direction, right? And this P moment which is making an angle theta with this electric field, right? So P E sine theta would be the torque one. Understood, Faizan? Because E1 is in the x direction, P is with theta direction. So PE and angle between P and E is theta. Yeah. And for the second case, for the second electric field, the second electric field is in the y direction, which is root 3E. Okay. So this is making an angle. What is the angle that it is making with this dipole moment? This is theta. So this would be 90 minus theta. Right. Right, Faizan? Yes. So the torque would be simply PE sine 90 minus theta. Right. PE sine 90 minus theta. And sine 90 minus theta is cos theta. So this is the magnitude of torque for the second electric field. And in this question, it is given that torque 2 equals to minus torque 1. Right. So if we consider only the magnitude, this would be equal to torque 2 would be equal to torque 1. So torque 2 is P root 3 E cos theta, and this is equal to PE sine theta. Okay, so P cancels, PE cancels, and we have to calculate what? The angle theta. So this would be root 3 cos theta equals to sine theta. So sine theta will go into the denominator. So this would be tan theta equals to root 3. So what would be theta, Tariq?
root 3.
Yeah, for what angle your tan? So tan is increasing. Just remember that your tan is increasing, right? This is pi by 2. So this is at 45, you have 1, right? Then you have 1 by root 3. So this would be, yeah, 60 degree. Yes, that's right. So 60 degree. Is that correct, Tariq? Yes.
Yes, sir. 60.
Yeah. So please note down the answer. Please take the screenshot of this question and note down the answer of this. Okay. So whenever you guys need me to scroll down the screen, guys, please tell me. Any doubt in this question? Tarif and Faisal.
No.
Yeah, so if you need me to scroll down the screen, guys, please tell me. Yeah. Tarif, noted up to this point.
Yes, sir.
So this is 0, this is 5 by 6, 5 by 4, 5 by 2. Okay. Okay, done, guys. Done. So Faiza, it is done. What about you, Tariq? Done, noted.
Yes, sir.
Noted or done?
Yes, sir, please.
Okay. So now the next topic would be electric flux and Gauss law. So you guys already know that, right? You already know about that for a closed surface, right? And if you place some charge, so the flux would be Q by epsilon naught simply, right? It will not depend upon size and shape of this surface. So for this surface also, for this surface also, right? What did I mean? So for this surface also, and for, let's say this is R, this is, let's say 3R. So all these surfaces have the same flux. Right. So from Gauss law, the closed integral surface integral of E dot ds is how much? This is Q by epsilon. Right, Q enclosed I should have. Is that correct, Tariq and Kaisa?
Yes, sir.
Yeah, so you guys must have calculated the flux through the surface of these kind of question you guys have done, right? This question flux through the surface of the cube. So this question and all those kinds. So if the charge is placed at this point, so these kind of question you guys have done, right? Electric flux question you guys have done, right, guys? So I will do the from the JEE point of view. Okay. So in the JEE point of view, you guys have already calculated the electric field due to infinite wire you guys have calculated. And this was the wire, you assume this Gaussian surface, and then you use this Gauss law, right? And then you found out that E is Q by 2 pi psi naught half. Right, guys, for this line wire. Right. Yes, and for the infinite sheet, it field due to infinite sheet. So what did you guys do? So this was the infinite sheet, right? So what was the electric field due to this infinite sheet? Yeah. Tarif, do you remember? Yes, Tarif. What is the electric? Yeah. Electric
is
field.
equal to sigma by 2 pi epsilon 0.
Yes, absolutely correct. Sigma by 2 epsilon, let's say what is this direction? Let's say R. Right. So this was, and same here also. So this would be sigma by 2 epsilon naught, but minus R. Right. So this was the electric field due to infinite sheet. But we have an electric plate also. Right. So the difference between electric or plane sheet and plate. Right, so this plane sheet has only one surface. But for the case of plate, we have two surfaces. Right, this is the inside and the charge are distributed like this. So whenever you place some charge, so this will be distributed in two parts, one in the left and one in the right. So this is the conducting plate. For the case of this infinite sheet, this is the electric field, guys, right? But for the case of this conducting plate, you will have three regions. So this will be the one region, this is the second region, this is the third region. So in this region, let's say this is 1 point and this is second point. Okay, this is one charge, this is second charge. So for this one charge, the electric field at this point would be where? In the left or in the right? Yeah. So let's say this is Q point, this is P point, and this is R point. Right. So electric field due to this one charge at this Q point would be where? In the left or in the right? Tarif.
Yes, sir.
Yeah, electric field due to this one distribution of charge at Q point. Where would that be? This, here, because this is positive, so this would be repulsive. So this is E1, right? And for this E2, this will also be in the same direction. Right, Tarif and Faizal, did you guys understand that?
Yes, sir.
And for this case also, at R point, this would again be E1 and E2. Is that clear, guys? One would again be repulsive, and this is also repulsive. Clear, guys? Yes, Tarif and Faiza, is that clear?
Yes, sir.
Yeah. And in the inside, and this distribution is same. So E1 equals to E2, right? Which is sigma by 2 epsilon naught. Understood, guys? So electric field at P would be E2 minus E1, which would be 0, right? And electric field at point Q would be E1 plus E2, which would be sigma by 2 epsilon naught by sigma by 2 epsilon. So sigma by epsilon. And same case for ER. So this will again be sigma by epsilon. So this is the difference between the conducting plate and this plane sheet. Understood, guys? Any doubt? So electric field inside the conducting plate will be always be 0. Electric field inside the conducting plate. So remember that for the case of this plane sheet, this is 2 by epsilon naught and this is sigma by epsilon. Understood? Any doubt in this, guys? Yes, Tarif and Faiza, any doubt?
No, sir.
Okay. So now we will use this property again and again. That electric field inside this conducting plate is 0. So just remember this property. Okay. So we have one question that we have a conducting plate. So why my conducting plate is? Yeah, I have. Okay. So I have this conducting plate, right? And the charge on this conducting plate is Q. Understood, guys? So, yeah. So the question is that how will the charge would be distributed in both the sides, right? So if I have a conducting plate whose charge is Q, total charge is Q. So how the charge will be distributed on this plate? Okay. So let's say that say that charge on this side is X. Okay. This charge on this side is X. So what would be the charge on this side? Sorry.
Yes, sir.
Yes. What did you say?
Sir, can you repeat the question again?
Yeah. So the total charge on this plate is Q. And my question is that how would the charge would be distributed on either of these sides of the plate? So I have assumed that, let's say that the charge on this side is X. So what would be the charge on this side?
Negative.
So what is the total charge?
0. Oh, total charge is Q.
Right. And I have taken X charge in this side. So what would be the charge here?
Positive.
Yes?
Positive.
Positive. Yeah. In both the sides, I have positive charge. So what would be the charge here? Let me give you a hint. Conservation of charges. So this side is X, total is Q. So what would be in this side? Faiza, what would be the charge in this side? And Tarif, if I tell you the answer, so then you will be thinking that you knew this answer. Yeah, Faiza, what is your answer? Negative. So both of you guys tell me that is this correct or not? Yes, conservation of charges. So Q minus X I am seeing. Is that yes?
I told negative.
You told me the difference.
No, sir, I told positive.
You told positive X. Okay. Maybe I didn't hear. Yeah. So you see that this is Q minus X, this is X. So what would be total charge? Q minus X plus X. So the total charge would be Q. So the conservation of charges fulfills, right? So in this side, if I have assumed that the charges are X, so this side would be Q minus X. Is that clear, guys? Yeah.
Yes.
Now what I will do is that, what do I know about the electric field at this point? What do I know about the electric field at this point? Tarif.
Yes, sir.
What do I know about the electric field at this point inside the plate? So, yeah,
It's 0.
zero. Yes, zero, zero. It is zero. Electric field inside the conducting plate is zero, right? So, which means that whatever this X charge is contributing, so X charge is contributing in this side, right? And this Q minus X charge is contributing in this side. Right, Faiza and Tariq, am I correct?
Yes, sir.
So this would be equal and opposite, so that the electric field becomes zero. So EX would be EQ minus X. Understood? Understood, guys?
Yes, sir.
Yeah, so this would be EX would be how much? EX would be sigma X by 2 epsilon naught, right? And Q minus X would be sigma Q minus X by 2 epsilon, right? Let me write it here. So this cancels. And what is sigma X? Area is same. So charge by area, right? What would be sigma X, Tariq? So sigma is how much? Surface charge density. Q by
Q by L.
right. So here what is charge? Charge is X. Area, let's say this is A. For sigma Q minus X, charge is Q minus X. Area is same. Am I correct? Are you guys getting this point?
Yes, sir.
So A cancels, and we have 2x is Q. So X would be Q by. So if I place some charge Q here, so this will distribute as Q by 2 here and Q by 2 here. Understood, guys? Is that clear, guys? Is that clear?
Yes, sir.
Yeah, so the question is that how the charge is distributed when I put some charge on the conducting plate. So the answer is that the charge will spread evenly on both the sides. Understood? Yeah, so did you guys note down this part? Difference between, did you guys note down this part? Yeah, Tarif and Faiza, did you guys note down this part?
I think, sir.
Okay. Oh, so please note it down, and then we will also note down the question. So any doubt, Tarif and Faizan?
No.
Yeah. So okay. Okay. So done, Tarif. Tarif
Yes,
done. Okay. So please note down this part. Yeah. Done this. So noted this question. Okay. Yeah. Done. Tarif done.
yes, sir. Done.
Okay. So now let us do this another problem. So in this question we have two plates. Right. So we have one plate which is this, and it has charge Q1, and the other plate which is this, which has charge Q2. So how many regions are there? 1, 2, 3, and 4. Okay. Understood, guys? So we have 4 regions, right? Yes, Tarif and Faiza, understood.
Yes, sir.
So what we do, and the question is that how are the charges distributed in these regions, right? So what we know is that if we assume that this plate, this side has X charge, okay. If this side has X charge, so this plate is facing this plate, okay. So if these plates are facing each other, so the electric field inside this these regions would be zero. So if this is X, so what would be this charge? Sorry, if this is X, so what would be this charge? Because total charge is zero in this region. So if this is X, so what would be this charge? Yeah. If we place, yeah, what did you say? If we play, yeah, minus X. Yes, Faizan, correct. So this would be minus X, right? Because just know this concept, because if we place two plates on this side, if they face each other like this, so if this has X charge, so this would contain minus X charge. Why? Because the total electric field in this region is zero, so the total charge should be zero, just because of Gauss law. So just accept this thing. Okay. I won't derive this, so just accept this. Understood, guys? Tarif, is that clear?
Yes, sir.
Yeah. So if this is X, so what would this be? Yeah. What would be the charge of this region? This is X, this is Q1, so what would be the charge of this region? We just did this just a moment ago. This side has X charge, so this charge would have yes, conservation of charges, conservation of charges. This has X, so this would have tariff. Because Faiza doesn't talk to the microphone, so only you are there. So yeah. So what would be the charge on this side?
Plus X.
Total is Q1. Total is Q1. This has X, so this would be
Q plus X.
Q plus X, because X charge is taken in this side. So this would be
Positive. Q.
right. And what would be the charge on this side?
Q2 minus X.
Minus of minus X, so that would be
Q2 plus X.
yes, you are right. So is that clear, Faiza? And very nice that you told me this answer. Yeah. So is that clear, Faiza? Yeah. Okay. Now, what do we know? What do we know about the electric field at this point? So let me draw the let me draw the overall diagram. So what would be the effective diagram? Right. Or let me calculate the electric field at this point. Let's say this point is P. Okay. So what would be the electric field due to this charge? Where would that be? In the right or in the left? Sorry.
Yes, sir.
So what would be the electric field due to this Q1 minus X charge? Right or left?
Right.
Right. Right. This would be E1. Okay. And what would be the electric field due to this X charge, Faiza? Right or left? Yes. At this point. Left. Absolutely right. So this would be left. This is E2. And there are also these charges. So remember that this is minus X. Remember that this is minus X. So what would be the electric field due to this third charge? Right or left? I am at this point only. I am just writing in here. So this I am calculating at this point. So Tarif, right or left? Due to 3.
Uh, so, right.
Right. Right. Because this is negative, so it will attract. Right.
Yes, sir.
And due to 4, what would be the direction, Faiza? Right or left? Oh, I know already. Okay. Yeah. So is that correct, Faiza? Left or right? Yeah, left. Correct. So we know that how many electric fields are there? 4. And all will contribute to give what? Yes, Tariq. All will contribute to give equal and opposite electric field, right? So this will contribute to give 0. So this means that E2 plus E4 would be E1 plus E2. Why? Because EP is 0. Am I correct, Taru?
Yes, sir.
Yeah. So E2 is how much? Where is E2? E2 is sigma x by 2 epsilon. Right. And E4 is how much? Sigma Q2 plus x by 2 epsilon. And E1 is how much? Sigma x by 2 epsilon. I am writing it x because I have taken the direction. So whenever I take the direction, so I don't consider the polarity of the charge. Understood, guys? Or yeah, understood. And due to E1, this would be sigma q minus x by 2 epsilon. So this cancels, right? And we have sigma x is q by sigma x is how much? X by a. And q2 plus x is q2 plus x by a. Sigma x is x by a. And this is q minus q1 minus x by a. Is that clear, guys? Tariq and Faiza, is that clear?
Yes, sir.
So A will all cancel and we will have, so this X also cancels and we have this Q2 minus Q1 equals to QX. So I can write X as minus of Q1, Q2 by 2. Is that clear, guys? Is that clear?
Yes, sir. Clear.
So this would be, so if I draw the resultant diagram, so yeah, so this would be, oh, my plates are very thick. So this is X, which means that this is minus of Q1 minus Q2 by 2. and this is minus of x, so this is q1 minus q2 by 2, and this is q2 plus what, q1 minus of q1 minus q2 by 2, so this would give me q2 minus of, okay, q2 minus q1. So how much that would be? This is q2 plus x, right? So q2 and x is minus of q2 minus q1 by 2, right? So q2 plus minus of how much is that? q2 minus q1. So q2 minus q1 by 2. So this would be how much? q2, and this would be 3q2 by 2, and this would be minus q1 by 2. Right? And this would be how much? q1 minus x. So q1 minus of x would give me how much? Minus of x would be q1 minus q2 by 2. So minus of x would be plus of q1 minus q2 by 2. Right, so this would give me 3q1 by 2 and minus of q2 by 2. Is that clear, guys?
Yes, sir.
Okay, so please note down this part. Please note down this part. Faiza, any doubt? Yeah. Okay, so please note it down, and let me see did I get the correct result. Yes. So this is one moment, guys. There is some mistake in my calculation. Let me check. So there is some mistake in my calculation. Okay. So this is E1, right? E1, and this is E3, right? And E4 is this one, and E2 is this one. Okay. So E2 is sigma x, right? So x plus q2, and this is x plus q1 minus x. So this would be, this is 2x and q2 minus q1. Right. So this is correct. So why am I getting this? Okay. Hmm. Oh, here. So this is yeah. So this is the mistake, guys. So you see that Q2 plus X is equals to Q1 minus X, right? Are you guys there?
Yes, sir.
So you see that this this Q2 plus X is Q1 minus X. So this will go in this side. So this would become 2X and this would become Q2 minus Q1. So this was the mistake. Right, so this was the mistake that I did. So X would be Q1 minus Q2. So that is why I was thinking that why I was getting now it will be correct. So now this is correct. Okay. Sorry about that, guys. So this would be simply Q1 minus Q2 by 2. This would be minus of Q1 minus Q2 by 2. And this would be Q2 plus X. So Q2 plus Q1 by 2 and minus Q1 by 2. So this would be this would be Q2 by 2. So Q1 plus Q2 by 2. Okay. And this would be how much? So this is Q1 minus X. So Q1 minus of Q1 by 2 plus Q2 by 2. So this would again be Q1 plus Q2 by 2. So now this is correct. Q1 plus Q2 by 2, Q1 minus Q2 by 2, minus this one and this one. So now you guys can note it down. Understood, guys? So this one, there was some mistake in this calculation. Yeah, please note it down. So that is why I was thinking that why I was getting this 3 factor in there. Okay. Please note down this part. Yeah, whenever you guys need me to scroll down the screen, you guys please do. Okay. So this you guys note it down in the later part. Okay. This is the final result, but you guys note it down in the later part. Yes, noted.
Writing, sir.
Yeah, so Tarif always sends me his homework, but Faiza, you don't send me your homework. Please, I will give you guys one question which is based on this only. So you guys, please send me the answer of that question. Okay, Tarif, so note it.
Yes, sir.
Yeah, so up to this point also.
Yeah, I'm writing.
Yeah. So remember that if you have two charges, right? So this would be Q1 minus Q2 by 2. This would be minus of Q1 minus Q2 by 2. This would be Q1 plus Q2 by 2. And this would be Q1 plus Q2 by 2. Okay. Yeah, done, guys.
Yes, sir.
So let me quickly, so on the basis of this, let's say that I give you this charge. Let's say this is 3Q and this is 4Q. So what would be the final distribution of the charges? So you guys can directly tell from here. So this would be 7Q by 2. This would be minus of 3Q minus 4Q. So minus Q by 2. This is Q by 2 and this is 7Q by 2. Is that so? Right? Did you guys understand that? Yeah, Tarif, understood.
Yes, sir.
Yeah, so let me give you guys a homework, difficult one, not this one. So you have Q minus 4Q and 2Q. So you guys find me what would be the final distribution of charges. Okay, the idea would be the same. Calculate the electric field at this point due to all these charges. Okay, understood. Yeah.
Yes, sir.
So please send me the homework of this question. Okay. Yes, Tarif and Faiza, please send me that link. Okay.
Okay, sir.
Yeah. Now we need to understand about the uh, electric field. Electric field due to a solid sphere. So what would be the electric field due to a solid sphere? Solid sphere meaning that what will I have? What kind of charge density will I have? Yeah, what kind of charge density will I have? For the solid sphere, what kind of charge density will I have? Faiza, what kind of charge density? So how many charge density do we have? Let me give you guys a hint. We have three kinds of charge density. Continuous charge distribution. So What would be the solid sphere type? What would be the type of solid sphere? Tarif, what would be the charge distribution of solid sphere? Yes, what would be the charge distribution of solid sphere? Guys,
Hello, sir. Is equal to Q by epsilon 0.
volume charge density. Oh, so you are telling me E equals to?
Yeah.
E equals to what did you say?
Q by epsilon 0.
Q by epsilon 0. No. So this is 5. Right?
Yeah.
This is 5. Okay, so for the solid sphere, we'll have this volume charge density. This volume charge density would be how much? This would be Q by V. Right? Understood, guys? Yes. So there would be two electric field for this solid sphere. One would be, let's say so this is a filled solid sphere, right? Let's say this radius is R. Okay. And I want to calculate the electric field inside. So there'll be two regions. One would be this, the other would be this. So E inside, right? And E outside. Understood, guys? So what do we know? We know about this. Let us calculate first E inside. So E inside, what do we know? We know about this Gaussian. So this is a sphere. So what kind of Gaussian surface we will take? Yeah. This is a sphere. So what kind of Gaussian surface we will take? Spherical, right? So yeah, so we have this radius R, right? And we take a Gaussian surface of small radius R. Okay, so in the small radius R, the electric field or this Gauss law will simply tell us that this is Q enclosed by epsilon. Is that correct, guys? Yeah. So this E is uniform, so this will be taken outside, and this is S ds and Q enclosed. We have to find out what is charge enclosed in this region only. So this will be integral of rho dV by epsilon naught. So is that part clear, guys? This is a volume integral. Is this part clear, guys? Yeah, because we have a volume charge density. So for the small volume dV, we will have a dq charge, right? So if we integrate this dq, so this way this would give us how much? This would give me rho dV. So this will give me the total enclosed charge, right? So let me write it as integral of dq, which is equal to integral of rho dq volume. Okay, so what will this integral of surface would give you? What will the integral of this surface would give you? Yes, this is a sphere, surface of sphere. So what would this would give you?
4 pi r.
4 pi r square. Capital R or small r?
Smaller.
Smaller, right? And this rho is taken outside. Volume would be how much? Total volume would be how much?
Q.
Yeah, volume of sphere. Volume of sphere 4 by 3 pi r cube. Right. So 4 by 3 pi r cube by epsilon. Okay. So 4 pi cancels, and we have r square, r cube cancels, and we have E is rho r by 3 epsilon. Understood? Yes, guys, understood.
Yes, sir.
Yeah, and you guys know that this charge density is uniform. So this charge density would be Q by total 4 pi by 3 R cube. So this charge density, volume charge density is uniform, right? So whatever is the total charge density, that would be equal to this. Understood? Did you guys understand this part? Yeah, because for small charge, this was this, right? 4 pi by pi r cube, right? Whatever this charge was, right? So this would be always the same. Understood? Let's say this was Q prime. So whatever the charge was inside, so this charge density would be uniform. The total and this, so this would be uniform. Understood, guys? So I can write rho as, yeah. So I can write rho as, so remember this result also, and I can write rho as 4 by 3. Oh, I can write rho as Q by 4 by 3 pi r cube, and this is 3 epsilon naught, and this is r. So 3 cancels, and 4 pi epsilon naught is how much? K Q R by R. So is that part clear, guys? This is the magnitude of electric field inside. Is that part clear? Yes. Yes, so electric field inside, this is inside, this is inside. So remember that E inside is rho r by 3 epsilon naught, or E inside is K Q R by R. So E inside is directly proportional to R. Is that part clear, guys? Is this part clear? Yes, Tarif, you are silent. So any doubt in this point?
No, sir.
Yeah, so please note it down. So we have calculated the inside part, and outside we will calculate in the next class. So in the next class, I guess this will be complete. And you guys, please send me the homework, okay? So then I can discuss about that problem in the next class. Yeah, you guys, please quickly note it down. Yeah, should I scroll down the screen, guys? Done, guys. Yes, Tarif and
Yes, sir.
yeah. Okay, so the outside part we will calculate in the next class. Okay. So you guys will see that the final result will. So E inside is varies as proportional to R. So what would be the graph? What would be the graph up to this point? E varies as R inside. So this is the equation of a what? Y is equals to X, Mx. What is this equation? Y is equals to Mx, guys. Tarif, what is this equation?
Straight line.
Straight line. So the graph would be this. Okay, so this is E varies as R. This is inside.